Remember in the last discussion, we left off with discussion about dumpy2fs, which basically provides us information about a file system that's on our server. Well, we can use another tool, tune2fs, to actually take that information and change it if we want to actually tune the file system. So let's go take a little look at that, what options we have with that one. Tune2fs is the utility, and I'll just do --help. And as we can see from here, we have a handful of options we can use. We can change the maximum number of remounts before the system is actually checked. We can add a journal file system. We can change the intervals at which the system is checked. Because remember, by default, after a certain number of mounts, the system will be checked. Or if it reaches a certain number of days, it will be checked also. You could actually set the I option to 0 if you don't want it checked at all for some reason. We also have that option about the reserved blocks. We talked about that, how certain blocks are reserved. 5% is reserved for root. Maybe we want to modify that. Maybe we want to turn it back to 0. We can do that with tune2fs after the file system has been created. That's the key point. And if we turn it back to 0 and then realize, hey, you know what, we really do want some reserved blocks, because if we said some of those system resources, root processes running that, we want to make sure continue running even after the file system has been filled. So let's go ahead and take a look at a few of those. First, what we'll do is type mount, and we'll see what we have mounted. We're going to play with this one right here, ext2 mounted on mount 2. Now, it's saying ext2, which means it's not journaled. That could be or could not be true. It could have been journaled and just not unmounted. But we're actually going to use the tune2fs. But before we do that, let's go into mount. I want to show you something here. Mount, I'll do an ls-a, and you can see that's the only thing we see in the file system. And if I do a dt and I grep for ext2 at this point, you can see the space that we're using is 1.8 megs in size. I show you this because it's going to look a little different once we put a journal on it. So let's go ahead and do that. So we should unmount it. Really, you want to unmount it when you're doing this. Maybe we should take a look at some information like similar to what we have with dumpy2fs. And we'll put the L option here and we'll say SDB2. And you can see the same type of information that we received from before with dumpy2fs. So we can see information about the UID, the magic number. We can tell right here that's not a journaled file system because there is no has journal designation on there. And we can also see that it's not clean. So maybe what we should do before we play around with it is clean it. So I'll run fsck on it. Now, fsck should never be run against a mounted file system. And if I try to unmount it right now, let me do that just to show you what will happen. To unmount it, it's going to say the device is busy, and it's busy because I am in it. Now, it could also be busy because a file's holding it. That's possible too, but right now it's because I am in it, so I have to get out of that. And then I can unmount, unmount that, and now we can run fsck to dev sdb2. Run it against that. It cleans it pretty quick. It's a very small file system. We'll run the tune2fsl, and we should see now that it comes up as marked as clean. Great. So let's go give it a journal. Why not? So tune2fs-j dev sdb2. Now remember, when we mounted it last time, the total size used was 1.8 megs in size. After I put a journal on it, you'll see that the size has grown, and the reason it will grow is because of the journal itself. Actually, I got that wrong, don't I? Yep, okay. Let's fix that first. SDB2, put the journal on it. Alrighty, so the journal is done. We'll do a tune2fs-l on dev sdb2, and we'll scroll up here, and sure enough, now we can see has journal. Fantastic. So it's a journaled operating system, and what we'll do now is mount it. Mount 2. We'll do a mount command again, and we can now see that mount 2 is ext3. 3. And if we do a df-ht on this, and we'll grep for mount 2, we can see that the size of the space used has changed, and that's because of the journal operating system. Now we can modify reserve blocks on this file system if we want to, so we can go back up here and we can say, come back in here and do a -m 0 for 0 blocks, no more reserve blocks, and then we could go back up and say, okay, you know what, we do want at least 1% of that reserved, so we'll say -1, and now we have 1%. We moved it down, so it gave ourselves back a little space. Before, we saw that when we tried to unmount the system when we were in it, it wouldn't let us unmount it. There may be other times that you can't unmount the system. Very typically, there's a file that has open on that system and you can't unmount it. There are two commands that we can look at to help us figure out what file is holding that file system open. First one is fuser and the other one is lsoff. Really, they provide the same functionality, and lsoff can do everything that fuser can. It does use a slight bit more CPU cycles to accomplish its task, but it's so powerful that it's definitely the tool you want to spend time getting to know. And the man page on lsoff is actually an excellent man page, because anytime we have examples in a man page, it's always a blessing. So you can see there's many things we can do. We can check for ports and IP4 addresses. We can check for file systems open on the network. Later on, when we get into the security side of our Linux classes and more advanced classes, we get very deeply into lsoff and what we can do as far as security goes. But in this case, what I'm going to do is just use it right now to find a system that's in use that I want to unmount. So I'm going to create a very large file here. I'll put this in the background so it won't interfere with us. I'll press enter there, and then I'm going to come back here, quit out of this. I'm going to now try to unmount the mount2 directory. And it comes back and says it's busy. And this is where I can do an lsoff on dev sdb2, and we can see what's causing this to be open, and more importantly, we can see the PID that's causing it too. So 3466 is the process that's causing this to be unmountable. Well, what I can do is now kill that process, and we'll talk about kill in our next lecture series. You can actually see I've run out of space on that. That's another problem we have here. Well, I can kill that process now, 3466. I'll kill it. And now I'll go back in and try to run that unmounted command again. And sure enough, it unmounts. So lsoff and fuser will pretty much do the same thing, but lsoff is definitely the one you want to get comfortable using. All right, next we'll be looking at LVM and RAID and just going over exactly what those topics are.